Now, in the motors, we have to go through with the concept of back EMF, back electromotive force. So, when current from the external electric source is passed through the armature of electric motor, armature coil rotates in the magnetic field. You will remember that armature coil rotates because of formation of couple. So, movement of couple that allows the armature coil to rotate. It cuts the magnetic lines of forces. When it cuts the magnetic lines of forces, it means magnetic flux will change and induced EMF is produced. So, the point to remember, when the coil cuts the magnetic lines of forces, induced EMF will be generated because of the change in flux. So here, this whole fact is obeying the Faraday's law of electromagnetic induction and the Lenz's law. Wherever we use Lenz's law is only explaining about the direction of induced EMF, whereas the production of induced EMF is explained on the basis of Faraday's law. So now, in the diagram, electric source is indicated, that is a battery, external electric source, there is a plug key, then RS, PQRS, and then that is we are coming towards a coil, rectangular coil, which is ABCD, and it will rotate about its axis. The axes are indicated by dotted lines. And wherever in the figure you are watching F will be equal and opposite forces, which is giving rise to couple, and couple will make the coil to rotate. And this rotation will be between north and south pole. That is, lines of forces will be between north and south pole. When the coil will rotate, the lines of forces will be cut. Due to cutting of the lines of forces, the flux will be generated, or there is rate of change of flux which will give rise to induced EMF, and that induced EMF will be equal to minus d phi by dt. According to Lenz's law, this induced EMF opposes the rotation of armature, because armature is basically cutting the lines of forces, that is changing the magnetic flux. The EMF induced works opposite to EMF applied by the external electric source. External electric source is in the form of HT battery, high tension battery, and opposes the motion of armature. This induced electromotive force is called back EMF. Greater is the speed of armature coil, greater is the back EMF. When we are saying that the speed of armature coil, obviously it will be angular speed. So in the coil, again you are watching external electric source, a key, and a coil ABCD, and F are equal and opposite forces. Then these equal and opposite forces will give rise to couple, and couple will compel the rectangular coil to rotate. At the time of start of the motor, back EMF is almost zero, and the current flowing in the motor is maximum as the speed of armature coil increases. Back EMF also increases. When the coil attains maximum speed, the induced EMF becomes constant and current reduced to minimum. Back EMF is directly proportional to angular velocity omega. When we use this term omega, omega will be either V over R, that is linear velocity divided by radius of rotation, or it can be replaced by 2 pi n. N must be small, and n is the frequency of rotation, and otherwise omega can be replaced by 2 pi over t. So omega is either V over R or 2 pi n or 2 pi by t. Omega is basically the angular velocity of rotation of armature, and the magnetic field B, that is for constant magnetic field, back EMF is E proportional to omega, or E is equal to K omega. K is constant. If E is applied EMF, capital E means applied EMF, small e means the back EMF, and R is the resistance of coil, that is the armature coil. Then the current flowing through the coil is calculated by simple Ohm's law, that is we take the difference of voltages, that is the applied voltage, and the back EMF, this difference is E minus E, and divided by R, this gives the value of current, that is current produced in the system. This particular phenomena is analog to the terminal voltage of the battery, which we have discussed in the Ohm's law. Or EMF, which is applied, is given by function E plus IR. Small e, that is the back EMF, will be estimated by function K omega. Omega will be V over R, 2 pi over T or 2 pi N. So we can estimate the current by computing the value of E in equation E is equal to E plus IR. So the value of current is estimated by function E minus K omega divided by R. In the beginning, that is at the time of start. We say the time of start, we assume T0. The time of start of the motor, omega is 0. Obviously, when it is not moving, there is no angular velocity. Therefore, I will be E over R. In this case, current will be maximum. As armature coil is made from copper wire, so its resistance is very small, so more current will be passing through it. When motor starts running, a very heavy current passes through the armature coil, the beginning, due to which motor may get burnt. So to prevent the burning of motor, we will make some arrangement. To prevent the motor from burning at the time of start, a special variable resistance is connected in series. Variable resistance is connected in series with the armature, and this is called starter. So what is a starter? Starter is the combination of variable resistance with the armature, and this combination will be in series. High resistance is connected in series with the armature coil. So effective resistance of the armature and high resistance will be very high. High resistance is connected in series with the armature coil with the help of starter at the time of start of motor. As the motor starts picking up speed, the resistance is gradually reduced till it becomes 0. Starter is used in high power motors but not in low power motors. Why it is so? Because its coil starts rotating with very high speed in short time. Now, power of electric motor. Power is generally the product of voltage and current. Here the back EMF is E and the current is I. So power of electric motor is the product of I and E. Efficiency of motor, which is generally expressed in percentage. So neta is the representation of efficiency of motor, and that is given by the ratio of work done by motor divided by energy taken from electric source by the motor multiplied W by P, that is work done by power multiplied 100. So we estimate efficiency in percents. Neta is back EMF over applied EMF multiplied by 100. In the symbolic form, it is given as small e over capital E multiplied by 100. So we will estimate neta always in percents. Generally, the energy of motor varies from 80% to 90%. The reason for the variation is because back EMF as well as the applied EMF are never constant. They vary according to time.